Hello students, we have to learn integration by parts. Integration by parts. Say this theorem. When we apply this theorem, if two different kinds of functions are present in multiplication, then we apply by part. Remember. Therefore, here theorem. If u and v are integrable functions of x, then prove that integral of u into v into dx is equal to u integral of v into dx minus integral of du by dx into integral of v into dx into dx. This result we have to prove. Proof is very simple. See here. If we have to prove this formula, then you remember carefully in your mind. We have to remember carefully. That means we have to get substitution. Instead of this integral, this part you keep in your mind carefully. If I have to prove this formula, then you remember carefully. Instead of this integral only, integral of v into dx, we have to carry substitution. This part you keep in your mind carefully, then immediately we can prove this formula. Remember, this is the important part. If we have to prove this formula of by parts, then you remember instead of integral of v into dx, we have to carry substitution. Therefore, see a proof. Let integral of v into dx equal to w. Then we write here differentiating with respect to x. Then what is that operator of derivative with respect to x? That is d by dx. We know d by dx of integral of v into dx because we know derivative and integral are verses of each other. Therefore, integral derivative cancel. Therefore, only v and is equal to on this side. We attach the operator of derivative, that is dw upon dx. Remember, that is very simple part. Then here we start in this manner. We know what is our definition of derivative. What is the definition of integral? The definition of integral started from derivative. That is, we know the definition of derivative d by dx of g of x plus c is equal to f of x. Then integral of f of x into dx equal to g of x plus c. Remember that definition we have to apply. That means we go by using derivative. Remember, because our definition of integration started from our definition of integral in this manner here. If integral of definition of integration we have to write if d by dx of g of x plus c equal to f of x, we imagine, then on this side we attach integral of f of x into dx is equal to g of x plus c. Remember, this is the definition of integration. Remember carefully in your mind. Therefore, this definition of all we have to apply. Therefore, starting point from derivative. Therefore, we start from derivative. Now, d by dx of u into w. Remember, u into w. Remember, because instead of this integral we start we let as a w. Therefore, d by dx of u into w. Then we know formula of d by dx of u into v. Already we know, but instead of v here only w is present. Therefore, immediately we expand. That is equal to u as it is. Then we take derivative of this function. That is d by dx of w plus w as it is, and we take derivative of first function. That is du by dx in this manner. Then see here, just write down here this definition we have to apply. Therefore, by definition of integration we get, see here, on this side we attach integral and derivative we eliminate. Therefore, same way, on this side we attach the operator of integral of, in this bracket, this quantity into dx. Remember, this quantity into dx and is equal to this derivative cancel. This derivative we minimize. Remember, therefore only u into w. This definition we apply. Therefore, definition of integral you remember carefully in your mind. Therefore, see here, how many terms are present in integral? Already we know in integration 2 terms, 3 terms, n terms are present in addition or in subtraction. Then we attach the operator of integration to every term. Therefore, here we attach, and simultaneously integral of u into this quantity, but this quantity in terms of original function as a v, because dw upon dx as a v we replace and into dx, because two integrals we carry two integrals separately we write down because here plus sign is present. Therefore, here plus integral of, I write down first du by dx and then w, but w is equal to integral of v into dx equal to u, and the value of w we carry the substitution integral of v into dx, and then finally we transfer this term on this side here positive. If we transfer, it becomes negative, and we get our standard formula integral of u into v into dx equal to equal to u into integral of v into dx minus integral of du by dx into integral of v into dx into dx. Therefore, you remember, proof is very simple. There is nothing. Remember, our starting point from derivative. Remember, because our definition started from derivative. Therefore, we start from derivative. I think you understand this theorem. Remember. Then see here, I write down here note, Liet or Ilet. See here, you remember this terminology, Ilet or Liet. Remember, that means here generally five types of functions are present. L means logarithm, logarithmic function. I means inverse, sin inverse x, tan inverse x, cot inverse x, like that manner. Algebraic, that is x square, 1 upon x, x plus 2. This is algebraic. Trigonometric, sin x, cos x. This is trigonometric. Exponential, 2 raised to x, 7 raised to x, 5 raised to x, e raised to x. These are this is exponential functions we discuss here. Remember, therefore, here 5 types of functions are present. Therefore, that 5 types of functions, out of these, this is orderly. Remember, which present first, that is our first function, because here 2 functions are present, first function and second function. Therefore, we have to decide which function we take first and which function we take second. Orderly, which is first occur, that is first function, and secondly, that is second function. Remember, that is very simple. There is nothing. Therefore, this terminology you remember carefully in our mind. Then here we have to carry examples. We carry examples. Remember, this result is very important. By parts, proof also. You remember, for point of examination. Remember, proof also important. Remember carefully in our mind. Then say one by one examples we carry. First example we carry. First example, evaluate. First example, I equal to integral of x into sine of x into dx. This example we have to evaluate. That is here. This is algebraic and this is trigonometric. 2 different kinds of functions present in multiplication. If this type of example is present, function in integral is present, at that time we apply by part. Remember, just we discuss here. Therefore, this terminology we use L, I, A, T, E. Therefore, which is first, algebraic first and then trigonometric. Therefore, first function as a x and second function as a sin x. Therefore, this is our u, this is our v. That part we keep in our mind carefully. And immediate we use that formula. Just we discuss here. Again, I write down here integral of v into dx equal to u integral of v into dx minus integral of du by dx and into integral of v into dx and into dx. This formula we have to apply. Remember. Therefore, here in our mind we carry this is first and this is second. We do not write down there as a u as a x and v as a sin x. That part we keep in our mind carefully. Remember. Therefore, here x first function as it is into second functions we take integral into dx minus integral of first functions we take derivative. We know d by dx of x, d by dx as x as a 1, d by dx as a 1. Then see here this part we have to write down, but this is the example. We know its solution we have to write down. We know this is standard formula, integral of sin x into dx equal to minus cos x. Therefore, we write down there minus cos of x. We do not write same part here. Remember, this is theoretical. Therefore, we write down here. But this is actual example. We know this is standard formula. Therefore, its value as a minus cos x and into dx. Then see here. Already we substitute its solution. That means here minus cos of x. Therefore, x in bracket minus cos of x. I replace its value. Minus become plus integral of cos of x into dx. And therefore, is equal to minus x into cos of x and plus, this is also standard formula, its value is the sine of x, and then finally plus c, because operator of integral from this step we eliminate by using our appropriate standard formula, and its result we know sine of x. Therefore, here r equal to, in this manner we evaluate this example. Remember, this is very simple. Remember, I think you understand this example. Then see here, number second, I is equal to, see here, I is equal to, second example, I equal to x into log of x into log of x into dx. Here, that is very simple. Again, this terminology we apply L, I, A, T, E. L means logarithmic and A means algebraic. Here, this is algebraic, this is logarithmic. Therefore, which first occur? Logarithmic is first occur. Therefore, our logarithmic function is first function and algebraic is second function. This part you keep in mind carefully. Therefore, say this is very simple. log of x first function as it is into second functions we take integral minus in integral its derivative we write down here d by dx of first function. Therefore d by dx of log x, that is very simple, d by dx of log x as a d by dx of log x as a 1 upon x. Therefore we write down there's its result directly we substitute, and this is our result. Which formula we apply? Integral of this formula we apply integral of x raised to n into dx equal to x raised to n plus 1 whole divided by n plus 1 plus c. And you remember this formula is not applicable for n equal to minus 1. That part keep in your mind carefully. Therefore here its result, that is x raised to 1 is present. Therefore immediate x square divided by 2 into dx. This formula we apply. Therefore here then is equal to, already we substitute its value, that is x square divided by 2. Remember same result, but this is the example, therefore we substitute its result here. Then here its result we know, its solution integral of x into dx, that is x square divided by 2, x square divided by 2. And this value we write first because we carry jumbling in angle. For that purpose we write first its result x square divided by 2 and into log of x. For our convenience we write in this manner. Minus this 1/2 I take outside of integral because this is constant quantity. Because this is 1/2 as a constant, immediately we take outside of integration and integral of x into dx because x square divided by x, that is by observation we carry simplification. Therefore equal to x square divided by 2 into log of x minus 1/2. Again its value we have to replace x into dx, just we replace same value, that is x square divided by 2 and plus c because this is indefinite integral. Therefore we write down there plus c, remember. Then some algebraic or numerical algebraic as well as numerical simplification will follow here. That means here x square divided by 4. Therefore x square divided by 4 we take common. Therefore x square, therefore I equal to final solution x square divided by 4 because 2 into 2. Therefore here 4 we have to construct. Therefore we multiply its numerator denominator by 2. Therefore we get here 2 into log of x and separately minus 1 and plus c. In this manner, this example we evaluate. I think you understand this part. That is very simple. Then here next example we carry number 3. Then here example number 3 we carry here example number 3. I equal to integral of x into tan inverse of x into dx. Again this terminology we apply. I means inverse function, A means algebraic function. Therefore, which function is first? This is tan inverse of x is first, and this is second because ordinarily here first as a inverse function, second as a algebraic function. Therefore, this terminology you remember carefully in your mind for your convenience. Therefore, here immediately we do not mention there. Here u equal to tan inverse x and v equal to x. That part we keep in our mind. Therefore, here equal to first function as it is tan inverse of x. This formula we apply. This is u, remember. Then here into integral of x into dx minus integral of its derivative d by dx of d by dx of u means first function, d by dx of tan inverse x. That is very simple. That is standard formula. Therefore, immediately we substitute 1 plus x square and its result we have to replace. Same part is present, but that is example. Its result we have to write down. What is its result? X square divided by 2 and into dx. Remember in this manner. Therefore, here integral of x into dx. Integral of x into dx. Its value first we write for our convenience. X square divided by 2 into tan inverse of x. Otherwise we can jumbling in angle. For that purpose we write first. Then here minus 1/2 I take outside of integral. Then integral of x square into dx divided by 1 plus x square. Then here this integral we have to evaluate. That is very simple. Here this is algebraic. Then if we observe numerators functions highest power and denominators function highest power are same. Here 2, here 2. If numerators function power and denominator function power same, at that time you remember carefully in your mind, we add as denominator to numerator. This part you keep in your mind carefully. If that is algebraic and highest power of numerator as well as highest power of denominator of the function are same, at that time we add this denominator to numerator. This part remember carefully in your mind. If this type of example is present, x square divided by 2 into tan inverse of x, then minus 1/2 integral of. Then here we have to carry adjustment. Which part we want? 1 plus x square. Then say already x square is present there. This 1 we take additional. Therefore minus 1 divided by 1 plus x square and into dx. Remember. Then here is equal to x square divided by 2 into tan inverse of x. Then minus 1 half. Then here in bracket. Then here we construct two integrals. We divide here as well as here. When we divide, this part cancel. We cancelize this bracket. Therefore integral of only dx. Remember, and we carry separately two integrals because here two terms are present at numerator. We divide here as well as we divide here. Remember. Therefore here when we divide it, then we get only 1 times dx, then minus integral of 1 upon or dx upon this dx upon 1 plus x square. This is standard formula. Remember, out of 7 integrals, this is formula number 4. Integral of dx divided by x square plus a square equal to 1 upon a into tan inverse of x by a plus c. By using this formula, immediately write its value. This is tan inverse of x. Remember, therefore here x square divided by 2 into tan inverse of x minus 1 half in bracket. What is its value? X. Then minus tan inverse of x, and we eliminate the operator of integral by using our appropriate standard formula, and then we introduce their plus c. Remember, in this manner. Then here I equal to final solution. Here tan inverse x, here tan inverse x. Therefore we take common. Tan inverse x we take common. Remember, as well as x also present, but we take only tan inverse of x as a common, and we write down there x square divided by 2 minus x divided by 2. Here x square divided by 2 and minus here, that is minus plus 1 half only, plus 1 half. Here minus plus 1 half tan inverse of x, and finally minus x by 2. So here minus plus, remember, and then plus c. In this manner we evaluate, or this is our final solution. I is equal to x square divided by 2 plus 1 half. 1 half also we take common, or in this manner we write down our solution. Remember, that is very simple. I think you understand this example. Remember. Let's see here. Next example we have to carry. Next example we carry. See here. Next example we have to carry. See here. That is this example. I is equal to integral of x square into e raised to 3x into dx. This example we have to evaluate. See, we observe carefully. That is this terminology. This is exponential function. Exponential function means 2 raised to x, 3 raised to x, e raised to x, like this manner. Algebraic. First algebraic and then secondly exponential function we take, because here first algebraic and then exponential. Therefore this part remember. Therefore here immediate x square as it is, integral of e raised to 3x into dx minus this formula I applied. Then here into d by dx of x square, that is simple, that is twice x, and its value same part is present, but this is example. Its value we have to write down. Therefore that is its value as e raised to 3x, the coefficient of 3 as this is x is linear, therefore its coefficient goes to denominator and into dx. Remember. Then here x square, just we replace its values here, e raised to 3x upon 3. Remember, minus 2 by 3 as a constant quantity we take outside of integration. Remember, that is x into e raised to 3x into dx. Then here again if we observe here algebraic into exponential, therefore again we have to apply by part. Therefore same result again we apply. Therefore here x square into e raised to 3x divided by 3, then minus 2 by 3, and we know when we apply by part, there are two terms. That part keep in your mind carefully. Two terms. Therefore we carry the bracket 2 by 3 in brackets here again here algebraic function as it is. Then see second functions we take integral. We know just we carry same steps again. We go in a short manner. Therefore its integral we have to carry. What is its integral? E raised to 3x divided by 3. Then minus in integral its derivative 1. Again here same part we have to write down. Therefore same part means e raised to 3x upon 3 and into dx. Remember carefully in your mind, into dx. In this manner we evaluate. Then here is equal to x square into e raised to 3x divided by 3. Then I multiply here, or we carry same way, that is same steps we carry 2 by 3 in bracket. Here x into e raised to 3x divided by 3. Then minus here. This is 1/3 I take outside of integral. one third, this one third, and integral of e raised to x into dx. Just please replace this value. Therefore, again, e raised to 3x upon 3, e raised to 3x upon 3, and the operator of integral will minimize, and therefore plus c in this manner. Remember. Then here, if we observe throughout, we observe carefully. When you multiply, here we get 9, but here we get 3 into 3 into 3, that is 27 we get. Therefore, if we observe 27 is our LCM, and if we observe these three terms, there e raised to x we take common. Therefore, here e raised to 3x common and divided by 27 as our LCM. Remember. Therefore, here e raised to 3x we take common. Remember. Then here we have to construct 27. Therefore, we multiply its numerator, denominator by 9. Therefore, 9 times x square in this manner. Then here 2 into 2, 9. Therefore, we have to multiply by 3. Then we get 27. Therefore, 3 into 2 minus 6 times x. Then here minus plus, and 27 already present. Already we take common, and that is plus 1 in this manner. That is here plus, not plus 1, because there 2 is present, because here 3 into 3 into 3, this part will be, but we have to multiply by 2, therefore 2 and plus c. In this manner, we evaluate this example. Remember, I think you understand this example. That is very simple. Step by step we carry this part, then immediately we can evaluate. Remember. Then here, by same way, next example we have to carry. See here, these examples you evaluate again and again. Therefore, here, next example, I equal to integral of log of x into dx. Here, log of x into dx. Here single function is present. But in our result there must be two functions, two different kinds of functions present. You remember, this is not standard formula. This is example, and this example we have to evaluate by using by part. And when we apply by part, then there must be two functions. Remember.